Okay. So how do you evaluate this integral? It has a Dirac delta function. That means this function only exists at x equals. You have to look at this. So this function,
X equals 2.
There we go. And then you have to figure out whether x equals 2 falls within the limits of integration or not. Good? Does it fall within the limits of integration? If it does, then all you have to do is go integration 0 to 3 x cubed delta x minus 2 2 to the power 3, and the answer is 8. Oh, I forgot the dx. Same question given slightly differently. 0 to 3 x cubed. How would you do this? It exists where? At x equals 4. Does it fall within the limits of integration? The answer is
0.
Good job. Does that make sense? Yes. Casey, you have a question.
So it's 0 because it doesn't fall in between the 0 and the 3, right?
Yep. What that means is, where is this function existing? What is this point?
X equals 2.
There we go. So if your limit of integration is 0 to 3, but then this function exists where?
X equals 4.
Good. So your limit of integration is from 0 to 3.
And it's outside of that little
And
range.
the function exists here. So what should your answer be?
0.
Done. Okay? So this Dirac delta function is actually quite an interesting thing. Mathematicians always make sure that we understand it, that Dirac delta function does not have a significance by itself. Okay, you cannot have like that function be by itself. It has to be within the integration for it to have a value. Okay? And so you cannot just put that function somewhere and say, oh yeah, there's this function. No, that's not how it works. So this brings me to the end of chapter 1. Yay! We will start chapter 2 tomorrow. Oh, and I also added like this example for you guys to try.